solve the following augmented matrix. So looking at this lovely matrix here, we have 1, 2, 3, a 4 by 4 coefficient matrix, and it's augmented with our column of constant terms. So the first thing I want to do is convert this matrix to its linear system form. So we want to convert to a linear system of equations. So we'll keep in mind here that each one of these columns is representing a variable. So column 1 is x sub 1, column 2 is x sub 2, column 3 is x sub 3, and column 4 is x sub 4. So looking at equation 1, we see that we have x sub 1 minus 3 times x sub 2, and this is equal to negative 5. Looking at equation 2, we only have the x sub 2 and x sub 3 terms. So this will be x sub 2 minus 2 times x sub 3 is equal to negative 6. Moving on to equation 3, we see that we only have the x sub 3 and x sub 4 terms. So our third equation is defined as x sub 3 minus x sub 4 is equal to positive 3. And then last but not least, equation 4, we only have the x sub 4 term, which is equal to 2. So I did not write this so that you can see it very clearly, but we do have an upper triangular form. And we can say, or we know that we have this upper triangular form because the last equation with the last variable is equal to a constant. So we can take this and back substitute it into the equation above it to solve for the missing x sub 3. So we can solve by back substitution. And let's give ourselves plenty of room. So here we go. We are going to go ahead and let x sub 4 be 2, since that is given. And we're plugging this into equation 3. So this is going to leave us with x sub 3 minus x sub 4, so this will be minus 2, is equal to positive 3. And adding 2 to both sides, we see that x sub 3 is equal to 5. So we'll now take this x sub 3 equals 5 and x sub 4 equals 2, and we'll back substitute them into this second equation. So here we go, plugging them into equation 2. We have x sub 2 minus 2 multiplied by x sub 3. So we're multiplying this by 5, and that's equal to negative 6. So we have x sub 2 minus 10 is equal to negative 6. And adding 10 to both sides, we are left with x sub 2 is 4. So we now have x sub 2, x sub 3, and x sub 4, and we'll take all three of these and back substitute them into equation 1 to solve for x sub 1. So plugging everything into equation 1, we have x sub 1 minus 3 times x sub 2, so minus 3 times 4 is equal to negative 5. So we have x sub 1 minus 12 is equal to 5, negative 5. And adding 12 to both sides of the equation, we are left with x sub 1 is equal to 7. And we've done it! Woohoo! We have found each entry of our solution vector, and we can make our final conclusion and say that the solution vector, vector x, which is in R4, so our solution vector has 4 entries, x sub 1, x sub 2, x sub 3, x sub 4, and we found this to be the vector 7, 4, 5, 2. And this is our beautiful final answer. And again, I encourage you to check this by plugging it back into each one of these 4 equations to make sure that we maintain equivalence.